In a rural area, only about 28% of the wells that are drilled find adequate water at a depth of 100 feet or less. A local man claims to be able to find water by dowsing, that is, using a forked stick to indicate where the well should be drilled. You check with 66 of his customers and find that 24 have wells less than 100 feet deep. Answer the questions below. Assume the independence assumption is met. Okay, part A. Write the appropriate hypothesis. So remember, the null is always equal. So the percentage of successful wells drilled by the dowser equals, and then in this case, 28%. You could have also written that HO, then P equals 0.28. Now, this guy is claiming that he can do this better than 28%. So is greater than 28%. Does that make sense? So you're looking for those key words in the problem. Okay, check the necessary assumptions. So it says to assume the independence assumption. We generally have to assume that. You just check with 66 of his customers, so we're not really sure about randomization. I'd have to say not satisfied. 10% condition, let's check that. So we're just saying that 10% of the this should be less than 10% of the whole population. We're assuming that. We'll say it's satisfied. Success failure condition, this is the one we have to work out. So what we're going to do here is take n times our p. So 66 times 0.28, is that greater than 10? Yes, it is. It's about 18.5. And then do 66 times 1 minus p. So 66 times 0.72. That's certainly bigger than 10. It's about 47.5. So we can say those are satisfied. And the question you probably have is, well, what do you do if they're not satisfied? We have to just proceed with caution. Okay, so one of them's not satisfied, but we're going to just have to go with it. So let's perform the mechanics of the test. So I'm going to go up to an open stat crunch. Okay, so I'm just going to run stat, proportion stat, one sample with summary. Okay, pulled that down a little bit. So number of successes, it looked like 24. Out of how many observations? 66. And we're comparing this to 0.28. And he actually said it should be greater than. And notice this is exactly what our null and alternative hypothesis were. This is in symbols and here was in words. You got to be able to do both. And then press compute. And here we go. So they got, I always look at the sample proportion just to kind of put it in context. About 36% of this guy's clients had wells with less than 100 feet deep. So there's our test statistic and p-value. It's asking for the p-value, and it says round to 3 decimals, so 0.065. Now explain carefully what the p-value means in this context. So I went back over here. I've forgotten I actually had this optional graphs p-value plot. This is a nice graph when you do this. Let me pull this over. So it gives us this screen here, but then we can click the right arrow button. And here's the graph of that. They've standardized these scores here. So this is our area right here. So the question is if the population were 28%, how likely am I to get what I just got, my sample? And it happens more than 0.05, which is generally our cutoff. So in this context, if his dowsing has the same success rate as a standard drilling method, the p-value is the probability of seeing the result as good as those of the dowser or better because of natural sampling variation. Yes. So what is our conclusion? So 5%, unless otherwise stated, is sort of what our benchmark is. And our p-value is greater than 5%, right? It's about 6.5%. So we fail to reject the null hypothesis. There is not evidence to suggest the Dowser has success rate higher than 28%, even though with our sample it was 36.3%. Statistically, another sample could be a little bit lower than that. Okay? I know that's sometimes unsatisfying, but that's how our statistics work, right? So we're trying to show in the long run what is most likely. We're unwilling to reject that. We set that 5% level. Now, if you're willing to err on one side or the other, and we'll talk about the types of errors you can make in another section, you could have moved that up a little bit to 10%. Okay, so I hope that helps. Hypothesis testing, it can be very tricky. It takes doing, maybe 20 of these before they start to kind of click.